Even when scientists were working on splitting the uranium and plutonium atoms for energy, they were also thinking about a process that was even more powerful. It's not called nuclear fission, it's called nuclear fusion. After the war, it was perfected, and true to theory, the US was able to make a new military weapon, a new bomb, the hydrogen bomb, or H bomb, that was 100 times more powerful than the original atomic bomb, or A bomb, dropped on Hiroshima. The 1950s saw a frightful escalation in building and testing these bombs, especially when our Cold War enemy, the Russian controlled USSR, kept matching or beating us in the race to build the biggest bomb. There were also verbal threats made by these two superpowers. It was so frightening that children in school had nuclear bomb attack drills like we now have fire drills. Many people were so afraid they built concrete bomb shelters in their backyards and filled them with a year's supply of food. The height of this insanity came when Russia decided to best the US by building a 100 megaton bomb. That means a bomb with the explosive force of 100 million tons of dynamite. Just before they were going to blow it up, the lead scientist, Andrei Sakharov, went to his superiors and suggested they scale down the bomb. He pointed out that a bomb that size will blow a hole all the way through the Earth's atmosphere. Since most of the energy would go to space, it would be useless militarily, and beyond that, nobody knew what would happen to our natural environments if you blew a hole all the way through the atmosphere. In the end, they made it 50 megatons. Eventually, the largest governments in the world got together and agreed that they had to stop polluting the world with fallout from these bombs. Today, there are strict limitations on testing these devices. So what's going on with fusion? This graph shows a property of atoms we're concerned with. The protons and neutrons of different atoms have slightly different masses. So, if you go out to uranium, atomic number 92, and split it to krypton and barium, you lose mass. Einstein showed that mass loss becomes energy, and we can calculate it with this equation, E equals mc squared. The reason fusion was so exciting is because it involved the combining of atoms, specifically hydrogen atoms, to form helium, and the energy change was much greater than it was for fission. Nuclear fission, in addition to being used for hydrogen bombs, is also the process used by the sun to create the energy of the sun. So let's wrap up fusion. The atomic bomb splits atoms like uranium-235 in two. The hydrogen bomb fuses atoms together like two hydrogens, and the main difference is fusion releases way more energy than fission. So why don't we use fusion in reactors in order to make electric power? In theory, it's the best source of energy ever discovered. Well, we tried. Many years and billions of tax dollars went to develop a fusion reactor. The biggest problem is that you have to operate at the temperature of the sun. No container can hold anything that hot. Then that problem got solved. The reaction is actually held in place by a magnetic field in the current design. Still, the technical challenge of doing that on a commercial scale economically has been too great. There are some pilot projects, but no fusion reactor is in sight.